आपण सुरुवात करूया. In last lecture, we have studied types of organic reaction. Mainly, all the organic reactions are classified into four main types. What are that types? Substitution, addition, elimination, and rearrangement reaction. These are the four main types of the organic reaction. Then we have studied what is meant by substitution, addition, elimination, etc. And also there is sub-classification. Substitution reactions are further sub-classified into electrophilic, nucleophilic, and free radical substitution, while addition reactions are further sub-classified into two types. One is the electrophilic and second is the nucleophilic addition. Okay, while elimination reactions are further sub-classified into two types, 1,1 and 1,2 elimination. Okay, and then last type is the rearrangement reaction. We have studied all the four types of that organic reactions in detail with their example also. आपण त्यामध्ये असणारा एक्झाम्पल सुद्धा स्टडी केलेला आहे. Actually, what is 1,2 elimination? What is rearrangement reaction? What is electrophilic and nucleophilic addition? What is free radical substitution, etc. Okay, then let us see next point. या टॉपिक मधल्या पुढच्या पॉइंट कडे आपण जातोय. Very important point. What is meant by reaction intermediates? Okay, here in organic reaction there is very important role of that intermediate. Now actually what is the intermediate? We know that in chemical reaction, what is the general trend? Reactants are first converted into intermediate, and that intermediate further converts into product. Okay, this is the general trend. Means each and every chemical reaction maybe takes place into number of steps. That chemical reaction may involve formation of intermediate, and that intermediates which are formed during the reaction are called reaction intermediates. And this is again a very, very important term related to the organic reaction mechanism. Means to study the organic reaction mechanism, to understand the reaction mechanism, we must know about the intermediates which are formed during that reaction. And therefore, in this topic, in this point, we are going to discuss some intermediates in detail. There are different types of the intermediates which are formed in organic reaction. For example, carbocation. Yes, this is a well-known reactive intermediate. Then second, carbanion. Then third one is the free radical. And then fourth one, carbene, nitrene, and lastly arine. Okay, here actually as per our syllabus we are going to discuss that all the reaction intermediate, but out of that 6 intermediate we have to study first 3 intermediates in detail and last 3 intermediates in short. यामधले पहिले 3 intermediates आपण डिटेल मध्ये डिस्कस करणार आहोत आणि लास्ट 3 जे आहेत जस्ट डेफिनेशन अँड एक्झाम्पल आपण बघतोय. नाउ लेट अस स्टार्ट विथ द first reactive intermediate, carbocation. Okay, now we are going to discuss that intermediate in detail, particularly in 5 steps. याचं डिस्कशन आपण 5 स्टेप मध्ये करतोय. फर्स्ट इज द इंट्रोडक्शन. फर्स्ट स्टेप इज द इंट्रोडक्शन. Second is the formation, means how that carbocation is formed, how it is generated. Okay, like that. And then next one is the structure. Actually, we have to study in short what is the structure, what is the hybridization of carbon in that carbocation, then how the bonds are formed, what is the geometry and bond angle of that particular species, etc. Then next is the stability. Here we are going to discuss comparative stability of different carbocation and what are the factors which are responsible for that stability. And last one is the reactivity, means we have to study some example of organic reaction which contain carbocation as an intermediate, in which there is a formation of carbocation as an intermediate. Okay, thus we have to study that first reactive intermediate carbocation in detail and in that 5 step. या 5 स्टेप मध्ये आपण त्याचं डिस्कशन करणार आहोत. Now let us start with the first step, introduction. Okay, now here directly going towards its definition. Before going to its definition, I will explain how the carbocation is formed. General example, suppose this is the general organic compound. Just suppose it having carbon. There are 4 covalent bonds, first, second, third and fourth covalent bond. Now there is a covalent bond between carbon and X. There is one covalent bond between carbon and X. We know that how the covalent bonds are formed. Yes, due to sharing of electron. Means in between that carbon and X, there is a covalent bond, means there is electron pair. Suppose in presence of polar solvent, suppose that covalent bond undergo heterolytic breaking. Now, what is heterolytic breaking? आपण आता मागे स्टडी केलेला आहे. During bond breaking, one of the atom acquire both the electron from the shared pair. And here also, during heterolytic bond breaking, suppose that bonded electron pair goes towards that X, then that X acquire negative charge. There is formation of that negatively charged X. Okay, now carbon acquire positive charge because during this bond breaking, electron pair goes away from the carbon and therefore that carbon acquire positive charge. Thus, when that bond between carbon and halogen, that bond between carbon and X, it undergo heterolytic bond breaking. Both the electrons from the shared pair, both the electrons from the bond that goes towards at X, it acquire negative charge while carbon acquire positive charge. Okay, and thus that carbon having positive charge. Okay, this is the carbon which having positive charge. Due to this bond breaking, electron pair goes away from the carbon, hence it acquire positive charge, and that positively charged carbon species is called carbocation. याला आपण कार्बोकॅटायन असं म्हणतो. आपल्या सर्वांना ही स्पेसिस माहिती आहे. But we are going to discuss that species in detail. त्याबद्दल थोडंसं डिटेल मध्ये आपण स्टडी करणार आहोत. Now let us start. Okay, this is our carbocation. Carbon having 3 covalent bond, there is a positive charge. Okay, now let us see the definition. आपण definition बघणार आहोत. But first about the some important points of that carbocation. We know that in carbocation, carbon having 3 covalent bond. There are 3 covalent bond, means in carbocation, valency of carbon is a 3. Generally, in organic compound, carbon having 4 covalent bond, but in this case, that carbon having 3 covalent bond means simply we can say that yes, it is trivalent species. It is trivalent. Here in carbocation, carbon is trivalent because it having only 3 covalent bond. Okay, then second point काय दिसतोय आपल्याला कार्बोकॅटायन मध्ये? Yes, carbon having positive charge means it is positively charged carbon species. Okay, this is the second point. Okay, त्यानंतर थर्ड पॉइंट आपल्याला काय दिसतोय? There are 6 electron. 6 म्हणजे कोणते? This bond contribute to electron, this bond contribute to electron, this bond contribute to electron. म्हणजे 3 bond प्रत्येकी 2-2. Thus there are 6 electron in its valence shell. Okay, and thus in valence shell of carbon in carbocation there are 6 electron. Okay, मग आपल्या समोर 3 प्रॉपर्टी आहेत. From that we can define that carbocation species. How will you define it? It is trivalent positively charged carbon species which having 6 electrons in its valence shell. Carbocation is trivalent positively charged carbon species in which carbon having 6 electron in its valence shell. त्याच्या valence shell मध्ये 6 electron आहेत. This is just about the definition how the carbocations are defined. Now that carbocations are denoted by R plus or they may be denoted by C plus also. C plus किंवा R plus या लेटरनं आपण त्याला डिनोट करू शकतो. Then it is electron deficient species. Why it is electron deficient? Because in carbocation there are only 6 electron in its valence shell, means it having 2 electron less to complete its octet, means there is a deficiency of electron. Okay, and therefore we can say that it is electron deficient species. Next point, yes, it is an electrophile. Carbon having positive charge, and we know that positively charged species are called electrophile. Here also carbocation is an electrophile because it having positive charge. Okay, also in chemical reaction that carbocation having tendency to accept electron pair. Why it accept electron pair? Because it is electron deficient. It having only 6 electron, it having 2 electron less to complete its octet, and therefore it having tendency to accept electron pair from another substance. And we know that according to the Levy's theory, suppose any substance accept electron pair from another, then it is Levy's acid, and thus it acts as a Lewis acid. Okay, this is just about the introduction of carbocation. We have studied definition and some properties of carbocation. Definition मध्ये आपण काय सांगितलं होतं? Yes, it is trivalent positively charged carbon species which having 6 electron in its valence shell is called carbocation. Properties मध्ये it is denoted as R plus or C plus. It is electron deficient species. Electron deficiency त्यामध्ये आहे. Then it is an electrophile because it is positively charged, means obviously it should be electrophile. Okay, and last, it acts as a Lewis acid because it having tendency to accept electron pair from another, hence it is Lewis acid. Okay, this is just about the introduction of carbocation, and this is the example of carbocation. Okay, this is the example. Carbon center having positive charge. There are 3 methyl groups attached to the center carbon. Yes, it is carbocation, example of carbocation. Okay, now let us see second step. यामध्ये second step आपण बघूया. Formation means how that carbocations are generated, how they are formed in chemical reaction. Okay, now first is the from alkyl halide. Already we have studied in the introduction how they are formed, but I will again revise it. This is suppose organic compound. This is organic compound. Then in presence of polar solvent, that bond undergo heterolytic breaking. या bondचं heterolytic fusion होतं. This electron pair goes towards X. It acquire negative charge while carbon acquire positive charge, and this is called carbocation. Okay, मग simply आपण काय म्हणू शकतो? How the carbocations are formed? Carbocations are formed due to heterolytic bond breaking. They are formed due to heterolytic bond breaking. Okay, then carbon acquire positive charge and there is a formation of carbocation. Okay, now let us see second method. यामध्ये दुसरी मेथड आपण बघूया from alkene. Okay, let us see example of alkene. Very simple example. CH2 double bond CH2. This is called ethene molecule. Suppose it comes in contact with H plus ion. तो H plus ion च्या सानिध्यामध्ये इथिन molecule आला. काय होतं? Here a pi bond between that two carbon is undergo breaking. Pi bond between that two carbon undergo breaking and there is a formation of new bond between one carbon and hydrogen. यामधला एक कार्बन आणि हायड्रोजन यामध्ये नवीन बॉन्ड तयार होतो. बघा इथं CH3 दाखवलेला आहे. while that another carbon, this carbon now acquire positive charge, त्यावरती positive charge देतो. Okay, this is just breaking of pi bond and formation of new bond between carbon and hydrogen. Therefore, obviously another carbon acquire positive charge and thus carbocation is formed. We have studied two methods for the formation or generation of carbocation. First by using alkyl halide and second by using alkene. Okay, this is the second step. Okay, now let us see next one is the third step is the structure. Actually, we are going to discuss or we are discussing about first and very important reactive intermediate carbocation. We have studied first two steps. One is the introduction and second one is the formation or generation of carbocation. Now let us see third step, structure. Now let us see, okay, this is our carbocation species. There is a central carbon atom. Now what should be the hybridization of that carbon? यामध्ये कार्बनचं hybridization काय आहे? Hybridization of carbon is sp2. In carbocation, the hybridization of central carbon is sp2. आपण याचा डिटेल डिस्कशन करणार नाहीये. जसं तुम्ही मिथेन मध्ये 12वी मध्ये स्टडी केलं असेल, व्हॉट शुड हाऊ द हायब्रिडायझेशन ऑफ दॅट मिथेन इज sp3. मग त्यामध्ये कार्बनचं इलेक्ट्रॉनिक कॉन्फिगरेशन, एक्सायटेशन कसं होतं, या सगळ्या गोष्टी आपल्या इथं आपण आता डिस्कशन करणार नाहीये. शॉर्ट मध्ये आपण स्टडी करतोय स्ट्रक्चर. तर एवढं लक्षात ठेवूया आपण, हायब्रिडायझेशन ऑफ दॅट सेंट्रल कार्बन इज sp2. हाऊ द sp2 hybridization occur? कशा पद्धतीने sp2 hybridization होतं? 1s ऑर्बिटल and 2p orbital mix up and recast. त्याची मिक्सिंग आणि रिकास्टिंग होते and there is formation of 3sp2 hybrid orbital. म्हणजे या ठिकाणी एक s आणि 2p ऑर्बिटल यांचं मिक्सिंग आणि रिकास्टिंग होतं आणि त्यापासून 3 नवीन ऑर्बिटल्स तयार होतात की ज्यांना आपण sp2 हायब्रिड ऑर्बिटल असं म्हणतो. Now in carbocation, hybridization of central carbon is sp2, means there are 3 hybrid orbital. There are 3 hybrid orbital. Now that 3 hybrid orbitals of carbon form 3 covalent bond. They form, suppose this is the central carbon. Okay, now sp2 hybrid orbital of that carbon and orbital of that R group, there is just axial overlapping to form covalent bond. Similar to that, here also covalent bond, here also covalent bond. Thus, that 3 hybrid orbital overlaps axially with the orbital of another carbon atom or another atom to form 3 sigma bond. 3 sigma bond त्या ठिकाणी तयार करतं. हा यामधला सेकंड पॉइंट असेल. फर्स्ट पॉइंट मध्ये आपण काय सांगितलं, हायब्रिडायझेशन ऑफ कार्बन इज sp2. सेकंड पॉइंट, 3 sp2 hybrid orbital form 3 sigma bond in carbocation. Okay, now we know that there is a sp2 hybridization, means one p orbital, there is one more p orbital which do not participate in the mixing, which do not participate in the hybridization, and that orbital is called as the 2pz unhybridized orbital. Means that carbocation also having unhybridized 2pz orbital, and this is unhybridized 2pz orbital, and it lies परपेंडिक्युलर टू मेन प्लेन. मुख्य प्रतलाला ते परपेंडिक्युलर असेल. म्हणजे या सर्व ॲटमचं आर ग्रुप आर ग्रुप आर ग्रुप आणि कार्बन ने लाईज इन अ सिंगल प्लेन, एकाच प्रतलामध्ये असतील. while that unhybridized orbital lies perpendicular to that main plane. हे मुख्य प्रतलाला मात्र हे unhybridized orbital perpendicular असेल. थर्ड पॉइंट मध्ये आपण ते सांगतोय, unhybridized 2pz orbital lies perpendicular to the main plane. Okay, now last point is the geometry and bond angle. Now tell me what should be the geometry here. Geometry should be trigonal planar. Okay, it looks like a trigonal geometry, and geometry is the trigonal planar, and bond angle should be 120 degree. Okay, this is a very common bond angle if hybridization is sp2. Okay, and thus here the geometry is a trigonal planar with bond angle 120 degree. This is just about the structure of carbocation. स्ट्रक्चर ऑफ कार्बोकॅटायन मध्ये जस्ट एक 4 पॉइंट आपण डिस्कस करतोय, 4 पॉइंटचं डिस्कशन आपण करतोय. यामध्ये फर्स्ट पॉइंट कुठला सांगितलेला आहे, इन कार्बोकॅटायन हायब्रिडायझेशन ऑफ सेंट्रल कार्बन इज sp2. ओके, नाउ that sp2 hybrid orbitals of carbon form 3 covalent bond. Okay, these are the 3 covalent bond. Then next point, there is unhybridized orbital which lies perpendicular to the main plane. ते मुख्य प्रतलाला perpendicular असेल. आणि last point, just geometry is a trigonal planar with bond angle 120 degree. Okay, this is just about the geometry is a trigonal planar geometry and bond angle is 120 degree. Okay, this is the 120 degree bond angle. Okay, this is about the structure of carbocation. Okay, now let us see next one. यामध्ये पुढची स्टेप आपण बघूया. नेक्स्ट स्टेप इज द डी आपण म्हणतोय त्याला स्टॅबिलिटी. ऍक्च्युअली देर आर सो मेनी कन्सेप्ट which affect on the stability of carbocation. For example, inductive effect, then resonance effect, mesomeric effect, etc. These are the different concepts. Okay, now let us see how the inductive effect influence on the stability of carbocation. यामध्ये स्टॅबिलिटी आपण स्टडी करतोय. मी काही एक्झाम्पल तुमच्या समोर ठेवतो, मग आपण कंपॅरेटिव्ह स्टॅबिलिटी बघूया. लेट अस सी एक्झाम्पल ऑफ कार्बोकॅटायन. सेंट्रल कार्बन having 3 bond with the hydrogen atom, carbon having positive charge. Okay, this is the methyl carbocation. Then suppose one of the hydrogen atom is replaced by methyl group, then it become primary carbocation. Okay, this is the primary carbocation. Then suppose one more hydrogen is replaced by methyl group, it becomes secondary carbocation. Suppose again all the 3 hydrogens from the that methyl are replaced by 3 methyl group, then it becomes tertiary carbocation. Suppose these are some of the example. तुमच्या समोर काही examples आहेत आणि आपण काय बघणार आहोत. Actually, what's about the stability of that carbocation, which is more stable among that all the 4. या सर्वांमध्ये कोणतं more stable आहे हे आपण बघतोय. Okay, first let us see just comparison between that first and second. आपण काय करूया, फर्स्ट आणि सेकंड जो आहे यामध्ये थोडंसं कंपॅरिझन आपण बघूया. ओके, फर्स्ट अँड सेकंड यामध्ये विच इज मोर स्टेबल. ओके, मग इन द सेकंड कार्बोकॅटायन किंवा याला आपण प्रायमरी कार्बोकॅटायन असं म्हणतो. हिअर देयर इज अ मिथिल ग्रुप अटॅच्ड टू सेंट्रल कार्बन. वी नो दॅट सेंट्रल कार्बन इज पॉझिटिव्हली चार्ज्ड. Central carbon having only 6 electron in its valence shell, means there is a deficiency of electron. आपण काय म्हणतोय सेंट्रल कार्बनला, इट इज इलेक्ट्रॉन डेफिशियंट. that central carbon is having positive charge means it is electron deficient, त्याकडे इलेक्ट्रॉनची कमतरता आहे, एवढी गोष्ट तुमच्या लक्षात ठेवा. सेंट्रल कार्बन ऑफ दॅट प्रायमरी कार्बोकॅटायन इज इलेक्ट्रॉन deficient because there is a deficiency of electron. Okay, now here there is a methyl group attached to that central carbon. We know that methyl group shows electron donating inductive effect किंवा आपण याला प्लस आय इफेक्ट असं म्हणतो. कदाचित तुम्हाला इंडक्टिव्ह इफेक्ट हा कन्सेप्ट झाला असेल किंवा मी पुन्हा एकदा रिवाइज करतो कशाला आपण म्हणतोय बघा. In between that methyl group and carbon there is a covalent bond and means there is electron pair, म्हणजे इथे इलेक्ट्रॉन पेअर असते. Now this electron pair is pulled towards one atom, ती एखाद्या ऍटम कडे ओढली जाते and that is called inductive effect. त्याला आपण inductive effect असं म्हणतो. There are two types of inductive effect, plus I and minus I. ओके, प्लस आय म्हणजे कशाला म्हणतोय आपण, इलेक्ट्रॉन डोनेटिंग इंडक्टिव्ह इफेक्ट. ओके, या ठिकाणी मिथिल ग्रुप जो आहे दॅट मिथिल ग्रुप हॅव्हिंग टेंडन्सी टू डोनेट दिस बॉन्डेड इलेक्ट्रॉन पेअर टुवर्ड सेंट्रल कार्बन. म्हणजे या मिथिल ग्रुप आणि कार्बनच्या मध्ये जी इलेक्ट्रॉन पेअर आहे ती बॉन्ड मध्ये असणारी इलेक्ट्रॉन पेअर, तो मिथिल ग्रुप काय करतो, इट डोनेट दिस इलेक्ट्रॉन पेअर टुवर्ड सेंट्रल कार्बन, म्हणजे थोडीशी या सेंट्रल कार्बन कडे पुश करतो, ढकलतो, अँड दॅट इज कॉल्ड एज द प्लस आय इफेक्ट. त्याला आपण इलेक्ट्रॉन डोनेटिंग इंडक्टिव्ह इफेक्ट असं म्हणतो. बरोबर. मग इथं काय होतं बघा, इन दॅट प्रायमरी कार्बोकॅटायन, या प्रायमरी कार्बोकॅटायन मध्ये मिथिल ऍक्च्युअली सेंट्रल कार्बन इज इलेक्ट्रॉन डेफिशियंट. सेंट्रल कार्बन इज इलेक्ट्रॉन डेफिशियंट, त्याकडे इलेक्ट्रॉनची कमतरता आहे. अँड हिअर दॅट मिथिल ग्रुप शोज इलेक्ट्रॉन डोनेटिंग इंडक्टिव्ह इफेक्ट, म्हणजे तो इलेक्ट्रॉन देतो, कोणाला देतो, त्या सेंट्रल कार्बन कडे देतो. अँड देअरफॉर दॅट प्रायमरी कार्बोकॅटायन बिकम्स स्टेबल. It becomes stable. Why it becomes stable? Due to plus I effect of methyl group. Already central carbon is electron deficient. आणि मग म्हणजे सेंट्रल कार्बन कडे इलेक्ट्रॉनची कमतरता आहे आणि त्याला जर इलेक्ट्रॉन देणारा ग्रुप आपण जोडला, फॉर एक्झाम्पल मिथिल ग्रुप इलेक्ट्रॉन देणारा आहे, देन दॅट कार्बोकॅटायन बिकम्स स्टेबल. And therefore this primary carbocation is more stable than methyl carbocation. म्हणून हा मोर स्टेबल आहे कोणापेक्षा, तर फर्स्ट पेक्षा, मिथिल कार्बोकॅटायन पेक्षा तो मोर स्टेबल असेल. ओके, दिस इज द स्टॅबिलिटी. हिअर देयर इज अ रोल ऑफ इंडक्टिव्ह इफेक्ट. ओके, नाउ कन्सिडर अनदर एक्झाम्पल. यामधलं पुढचं एक्झाम्पल कडे आपण जाऊया. पुढचं एक्झाम्पल आहे हा आपला सेकंडरी कार्बोकॅटायन. In secondary carbocation there is again two methyl groups. There are again two methyl group, means there is a more plus I effect. Here also central carbon is electron deficient. There are two methyl groups which shows plus I effect, and therefore this carbocation is more stable than primary. तो या primary पेक्षा आणखीन जास्त more stable असेल. Okay, what's about the tertiary carbocation? There are again three methyl groups. Therefore again there is all the three methyl group shows plus I effect. Plus I effect दाखवतात, म्हणजेच काय, मी पुन्हा एकदा सांगतो, या मिथिल ग्रुप आणि सेंट्रल कार्बनच्या मध्ये जो बॉन्ड आहे त्यामध्ये असणारी इलेक्ट्रॉन पेअर जी आहे, दॅट मिथिल ग्रुप पुश दॅट इलेक्ट्रॉन पेअर टुवर्ड सेंट्रल कार्बन. सेंट्रल कार्बन कडे इलेक्ट्रॉन पेअर ढकलतात आणि ऑलरेडी सेंट्रल कार्बन कडे इलेक्ट्रॉनची कमतरता आहे आणि जर कोणी इलेक्ट्रॉन देणारा त्याला आपण जोडला, then that carbocation becomes more stable. Hence here tertiary carbocation is more stable than secondary, and which is more stable than primary, and which is more stable than methyl carbocation. This is just a role, this is just influence of inductive effect on the stability of carbocation. Okay, now what should be the statement? Yes, here methyl group shows electron donating inductive effect, and hence tertiary carbocation is more stable than secondary, which is more stable than primary carbocation. Okay, similar to that inductive effect, there is also role of resonance effect. There is also role of hyperconjugation effect. How the stability of carbocation is influenced by that inductive effect. This is just about the stability. Okay, now this is the fourth step. आपण कार्बोकॅटायनचं स्टडी करतोय. यामध्ये आतापर्यंत आपण 4 स्टेप स्टडी केला. इंट्रोडक्शन, देन सेकंड वन इज द स्ट्रक्चर, देन थर्ड जनरेशन, स्ट्रक्चर, देन स्टॅबिलिटी, आणि यामधली लास्ट स्टेप आपण स्टडी करतोय रिॲक्टिव्हिटी. म्हणजे काय आपण स्टडी करणार आहोत, एक्झाम्पल ऑफ ऑर्गॅनिक रिॲक्शन. यामध्ये एक्झाम्पल आपल्याला स्टडी करायचं आहे, एक्झाम्पल ऑफ ऑर्गॅनिक रिएक्शन विच हॅव्हिंग कार्बोकॅटायन एज अन इंटरमिडिएट. Let us see a simple example of organic reaction. Okay, this is the ethene molecule. Yes, it is ethene molecule CH2 double bond CH2. When that ethene molecule is created with HCl, आपण त्याची रिएक्शन HCl बरोबर केलं, काय होतं या ठिकाणी? इन फर्स्ट स्टेप आपण हे एक्झाम्पल ऑलरेडी पाहिलेलं आहे. ड्युरिंग इलेक्ट्रोफिलिक ऍडिशन रिएक्शन, during electrophilic addition reaction, I will explain same mechanism, same reaction. Okay, in first step what happens? In first step addition of H plus ion takes place to one carbon. यामधल्या H plus ion चे addition पहिल्या स्टेप मध्ये एका कार्बनला होते. Means that pi bond undergo breaking. यामधला pi bond break होतो and new bond between one carbon and hydrogen takes place. या दोन्ही मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. ओके, CH3 दाखवलेला आहे मी इथं पहिल्या कार्बन वरती. While that second carbon atom it acquire positive charge, त्यावरती इथं पॉझिटिव्ह चार्ज येतोय and thus there is a formation of positively charged species and this is called as the carbocation. हवं तर मी पॉझिटिव्ह चार्ज थोडा या बाजूला दाखवतो कार्बन वरती. ओके, and that species is called carbocation. Okay, this is just first step. मग सेकंड स्टेप मध्ये काय होतं? इन सेकंड स्टेप that Cl minus ion now attack on the positively charged carbon. याचा अटॅक याच्यावरती होतो. Means there is a formation of bond between that Cl and carbon आणि there is a formation of ethyl chloride molecule. Okay, this is just addition of HCl to the ethene molecule and we get the ethyl chloride, but that reaction takes place in two steps. In first step there is addition of electrophile, there is addition of H plus ion to one carbon atom, then we get the carbocation. That carbocation further react with Cl minus, we get the ethyl chloride and that reaction involve formation of carbocation as an intermediate. म्हणून आपण ही रिएक्शन स्टडी केलेली आहे. Just there is formation of carbocation as an intermediate. Okay, now let us see one more reaction. Yes, SN1 reaction. All of you are very well known about that reaction. हे सुद्धा आपण स्टडी केलेले आहे. पुन्हा एकदा रिवाइज करतो. SN1 रिएक्शन किंवा या एक्झाम्पलला आपण अल्कलाइन हायड्रॉलिसिस ऑफ टर्शरी ब्युटिल ब्रोमाइड असं म्हणतो. बरोबर? Okay, this is starting material is our tertiary butyl bromide. This is tertiary butyl bromide. When that tertiary butyl bromide is heated with KOH, त्याची रिएक्शन आपण KOH बरोबर केलं, काय होतं? इन फर्स्ट स्टेप बॉन्ड बिटवीन कार्बन अँड ब्रोमीन इट अंडरगो ब्रेकिंग. दिस इज हेटेरोलिटिक बॉन्ड ब्रेकिंग and electron pair goes towards bromine, it acquire negative charge, म्हणजे इथून Br मायनस बाहेर पडतं and carbon acquires positive charge and that positively charged carbon species is an intermediate and this is nothing but a carbocation. Okay, in first step there is a formation of carbocation. This is heterotic bond breaking. Now in second step that OH minus attack on the carbocation and there is a formation of tertiary butyl alcohol. There is a formation of bond between carbon and OH and we get the tertiary butyl alcohol. Okay, this is SN1 reaction called as alkaline hydrolysis of tertiary butyl bromide. Here tertiary butyl bromide converts into tertiary butyl alcohol. Okay, this is just about the reactivity. We have studied some examples of organic reaction in which there is a formation of carbocation as an intermediate and this is just about the first reactive intermediate कार्बोकॅटायन. आपण पहिला रिएक्टिव्ह इंटरमिडिएट जो आहे त्याचा आपण स्टडी केलेला आहे इन डिटेल. मग असे मी सांगितलं होतं आपण थोडंसं डिटेल डिस्कशन करतोय पहिल्या 3 रिएक्टिव्ह इंटरमिडिएटचं. मग त्यामध्ये इंट्रोडक्शन असेल. इंट्रोडक्शन मध्ये आपण काय पाहिलं? हाऊ दॅट कार्बोकॅटायन इज डिफाइन्ड. त्याची डेफिनेशन काय आहे? द ट्रायव्हॅलंट पॉझिटिव्हली चार्ज कार्बन स्पेसिस in which the carbon having 6 electron in its valence shell is called carbocation. This is the definition. मग त्यामध्ये काही प्रॉपर्टी सुद्धा आपण सांगितल्या होत्या. How it is denoted? It is an electrophile, it is electron deficient, it acts as a Lewis acid, etc. त्यानंतर सेकंड पॉइंट यामधला होता जस्ट जनरेशन. हाऊ द कार्बोकॅटायन्स आर फॉर्म, हाऊ दे आर जनरेटेड. यामध्ये 2 मेथड आपण पाहिला, बाय युजिंग अल्किन अँड बाय युजिंग अल्किल हलाइड. त्यानंतर थर्ड स्टेप यामधली कोणती होती? जस्ट स्ट्रक्चर. मग स्ट्रक्चर मध्ये सुद्धा महत्वाचे जे 2-4 पॉइंट्स आपण बघितले होते. स्ट्रक्चर मधला महत्वाचे 2-3 पॉइंट्स कुठले आहेत? तर हायब्रिडायझेशन कार्बनचं काय आहे? व्हॉट इज द हायब्रिडायझेशन ऑफ कार्बन sp2. देन हाऊ इट फॉर्म 3 सिग्मा बॉन्ड. तो 3 सिग्मा बॉन्ड कसे तयार करतो? त्यामध्ये अनहायब्रिडाइज्ड ऑर्बिटल आहे PZ. इट लाईज परपेंडिक्युलर टू दॅट मेन प्लेन, मुख्य प्रतलाला परपेंडिक्युलर असेल. आणि शेवटचा जॉमेट्री ट्रायगोनल प्लेनर अँड बॉन्ड अँगल 120. दिस इज स्ट्रक्चर. ओके, त्यानंतर आपण पुढचा पॉईंट पाहिला, स्टॅबिलिटी. हाऊ द इंडक्टिव्ह इफेक्ट अफेक्ट ऑन द स्टॅबिलिटी ऑफ कार्बोकॅटायन. मग त्यामध्ये काही एक्झाम्पल्स आपण बघितलं. मिथिल कार्बोकॅटायन, प्रायमरी, सेकंडरी अँड टर्शरी कार्बोकॅटायन. वी हॅव स्टडीड कंपॅरेटिव्ह स्टॅबिलिटी अमंग दॅट डिफरंट एक्झाम्पल. Okay, and here there is a role of plus I effect. That alkyl group, they shows plus I effect. There is an electron donating inductive effect, and therefore that actually central carbon is electron deficient, and if any electron donating group is attached to that carbon, then that carbocation becomes stable, and hence among that all the tertiary carbocation is more stable. Okay, then we also studied last point, reactivity. Just examples of two chemical reaction. One is the electrophilic addition reaction of HCl to the ethene molecule. That reaction involves formation of carbocation as an intermediate. And then second example is the SN1 reaction, alkaline hydrolysis of tertiary butyl bromide. Here in the first step, that bond breaks heterolytically, there is formation of carbocation. In second step, nucleophile attack on the carbocation to form tertiary butyl alcohol. Okay, this is the just about the first reaction intermediate कार्बोकॅटायन. मग याचा आपण डिटेलमध्ये डिस्कशन केलेलं आहे. ठीक आहे, यामध्ये आपण पुढचा इंटरमिडिएट स्टडी करणार आहोत कार्बॅनियन आणि त्याचबरोबर फ्री रॅडिकल.